there it is. Eagle Prime. Let me show you its features. So I'm here in Oakland, California, and this is Matt Orline, CEO of Megabots Inc. So, thanks for having me.
Yeah, absolutely.
And thanks for showing me that beast. Wow. Have you ever seen something like that? I have never.
It's a pretty impressive robot. This took us about a year and a half to build, cost about $2.5 million. Team of engineers and fabricators, and it's got a Corvette engine in it.
Corvette engine.
My favorite loadout is the chainsaw and the claw, because you can really get a lot of good hand-to-hand manipulation done with it.
Chainsaw with Mega Robot? How cool is that?
But we also have pneumatic cannons, and we have a giant drill, and also a giant knife that we can swap on as well.
You don't have a slingshot?
We don't have a slingshot yet.
That can't be. That can't be. We need to fix that.
That's right.
But first, I'd like to look at a few details, because I want to understand how this thing works.
Yeah, absolutely.
Wrong?
Yep.
Let's do it. Okay.
This robot's powered by a gasoline engine. It's a GM LS3 V8 engine. That engine turns 3 big hydraulic pumps, which pressurize the hydraulic system. So 4,000 PSI goes to all of the hydraulic actuators in the robot. And the hydraulic actuators control the arms and the treads and all the movement of the robot. So
that's a very serious piece of hydraulics.
Exactly.
And the chains, are they also operated by hydraulics, or is this like a direct transmission?
Yeah, the treads are powered by a hydraulic motor.
Okay.
And so, yeah, the hydraulic motor, you apply hydraulic pressure to it, and then turns the treads.
Okay. Let's look at the engine. So these are fans to cool it, right?
Yeah. So these are all radiator fans. There's a ton of cooling that needs to happen because this engine is used to being in a car that goes down the freeway at 60 miles per hour.
But it does have some battle scars. Like,
it does.
Up there I can see one. Seems like that was from a robot that had like a knife.
These scratches and dents are all real.
And then I can also see some ripped off components here. That was probably like decoration.
Fiberglass
right?
armor has been torn off.
Yeah. Okay.
So it's seen some battle.
But it is alive.
It's alive, and for now.
Now, when Matt invited me to come over to look at the robot and play around with it a little bit, I immediately said only on the condition that I can attach a slingshot to it. Now, it is not designed to hold a powerful slingshot, but of course, if I look at this claw here, that looks like a slingshot in itself, right? So maybe it would be possible to attach the rubber to this claw here, and then you would have to attach the release that I made, that I'm going to present to you later. I would have to attach it to the saw blade arm here, so that the robot can somehow but I guess in order to see if that is feasible, we will have to fire it up, burn some gas, and see how far we can stretch the arm, so I can figure out what is the best way to make this happen. Part of the challenge I already mastered home in Germany, because this needs a release. We need to be able to pull on a string, and later on in the final version that would go all the way like to a servo, so people could attach to some button inside of the robot, and then it would open. And the way how this works is you put the shot put ball right in here, so, okay. And then you have to pull on the string, it opens and releases the shot. Very, very simple. Now we have to attach this release to the end of the chainsaw, and I'm planning to do this with rope so that it maintains flexibility in directing the shot to any place we want. And then we'll simply attach the rubber band to the end of the claws here, because that's like a slingshot in itself. And then we'll simply have Eagle Prime opening its arms like this, and then so as you see, I clamped this in with a piece of wood so that the force of the clamp is spread over a larger surface here. And then as you can see here, I folded the rubber a few times. Maybe you want to look at that from here. So that the rubber band in stretched condition is not coming into contact with the sharp edge here of this piece of steel. And now it's time to test if it holds the draw weight, because this is rubber. This means it takes the exact same draw weight to stretch out this thin piece to the max than to stretch out the entire long piece. Of course, stretching it really long adds a tremendous amount of force, but to test if this holds, all I have to do is pull on it with full force and be prepared for the impact of the rubber should this come loose. Okay. It's holding perfect. We have a go. So this is the pouch that I designed, and right now we have the test thing, which is just a plastic ball in here, because when we test it we don't want to go ahead and use the steel ball first. So we're going to start testing it with the plastic ball. And as you see, the pouch sits in here, and the pouch is made from a super strong industrial material that's usually used for high pressure tools. And then the thing is just working like so. And this is our test cell. See, it weighs next to nothing. It's actually from a toilet. Our test setup is now complete. As you say, we put a little bit of tension on it to see if everything works out. See the attachment, and you can see that the release is actually beautifully aligned. And attach the rope to this. And if I would now pull on this little piece of paracord, the shot would fall. And as you see, I can really go out of the way of the shot very easily. So I hope my safety t-shirt is going to take care of all of this. I think it's super cool. Now, and as you see, it's still the plastic body. So this is not yet the shot put, because we really don't want to do anything dangerous. All right, 3, 2, 1, go.
Okay, so what are we doing here?
Now that we know that it works in principle, we are a little bit skeptical how the steel ball will behave. Therefore, we'll start by not drawing it out all the way, and also putting the wire very, very, very close to the steel ball or to the fork, so that we can be absolutely certain that we hit it. And also, it's dedicated. The only thing we decided is that we don't want to move the wire far back, because we don't really know where it's going to hit, and we don't want to risk that this thing is going to bounce off the concrete floor, flying around wildly. Even though there is nobody there, we still don't want to damage other people's property. Therefore, it's a close shot, and you can only look forward to what's going to happen when we drag this out into the field. I guess that was a German shot put, because did you see how tidily it closed the door after itself? And here it is. And the amount of damage is just magic. Not only did it really kick a dent in it, but I think it ripped the entire part off here. Yeah. This entire thing came out. And all these screws here were torn out so that, yeah. All right. Maybe we switch it back from delicate to normal. So what do you think, man? Was it worth while the day?
Well, it is certainly a unique weapon. I've never seen Eagle Prime build a slingshot before, and I never imagined it wielding one.
Well, this was a major success, and I'm happy that I came over. And now it's time for some beers, by the way, before I fly back tomorrow. But in any case, I think there is potential. We can increase it and we can really make it more fun.
Yeah.
But we will have to figure out how and when and how much it would cost and how we can set it up.
I would love to add a button in the cockpit that releases the
That would be
slingshot.
very simple, because the release works super easy and there's a very low amount of force that you have to apply to the string. Well, other than that, I want to make sure that you guys check out the version of the video that Matt made. You can find the link here after the video is finished. Click on it, and you should subscribe to his channel, and also check out his Instagram, pretty much everything, because it's worth it. So, I hope you liked this, because that's it for today. Thanks and bye-bye.